Alright, so in this video I'm going to run through how to write ionic equations. As it says here, they show the ions involved in a reaction. And often what they do is they give you a full balanced chemical equation and they ask you to turn it into an ionic compound. And to do that, you're going to need to know what types of substances will split up into ions. So I've got it written for you here. If it's an ionic compound and it's molten or aqueous, it will split into ions. And if it's an acid or an alkali, it will split into ions. Anything that's not in this category, or one of these categories, will just stay exactly the same. It's going to start off with just an exercise looking at what splits and what doesn't, and if it does split, how do we work out what the ions are. First one I've done for you, NaCl is ionic and it's aqueous, so it splits. I can see I've got sodium and chlorine, so all I do is I separate the sodium from the chlorine, and because I need to show them as ions, I need to put charges. Sodium's in group 1 with a +1 charge, chlorine's in group 7 with a -1 charge, and that will always be the case regardless of what they were bonded to, regardless of what the formula was. MgO is ionic, it's solid, therefore it's not going to separate into ions. MgCl2, ionic and aqueous, and will separate. So again, I showed the Mg and the Cl separate. Because magnesium's in group 2, it's got a 2+ charge. Because chlorine is in group 7, it's got a -1 charge. So again, notice it was Cl here and it was Cl2 here, but that hasn't affected the formula of the chloride ion. It's in group 7, so it's always Cl-. What you will notice though is the small 2 that I've written here, I'm now writing as a large 2 over here. What this formula here, MgCl2, shows you is you've got a magnesium bonded to 2 chlorines, and you'd have a chlorine on each side of the magnesium. The chlorines aren't actually bonded to each other, and this small number 2 tells me that everything's kind of bonded together. But this big number 2 tells me that the Cl- ions are not forming a bond with each other, that they exist totally separately. And the reason they'll exist separately is because they're both negative, so they repel each other. So to write Cl- with a little 2 would tell me that they were bonded to each other. They can't be, they repel each other, so I switch that to a big 2 to show that they're totally separate. Okay, and remember, even in MgCl2, the chlorines aren't actually bonded to each other. They would be on either side of your magnesium. Next one I've got is KBr. It's ionic, it's aqueous, it will split. Potassium's in group 1. That means it's got a +1 charge. Bromine's in group 7. It's got a -1 charge. Li2O is ionic, but because it's solid, it won't split into ions. LiBr is ionic and aqueous, so it will split. Lithium's in group 1, +1 charge. Bromine is in group 7, -1 charge. So again, you can see bromine is bonded to 2 different things in 2 different formula, but the formula of the ion is always the same, -1 charge, because it's in group 7. Next up, NaOH, it's ionic and it's aqueous, so it will split. It's also an alkali, so it will split. But what you need to notice here is you've got your polyatomic ions. So OH is a polyatomic ion, so is SO4, so is NO3. You need to be familiar with your polyatomic ions, because when I'm doing this, I'm not going to separate the O from the H. I'm going to leave OH together because it's my polyatomic ion. Sodium is in group 1 with a +1 charge. The hydroxide ion, OH, has a -1 charge. So don't separate the O from the H. It's a polyatomic ion. It stays together. HCl, covalent but aqueous, so it splits into ions. H2SO4, it's an acid, it's going to split. As I said, it's got one of the polyatomic ions. It's got the sulfate ion, which is SO4. So I'm not going to separate those. And you need to know this formula. You need to know it's SO4, and you need to know it's got a -2 charge. I've also got hydrogen. Hydrogen is always going to be +1. And again, I can see from my formula I've got 2 hydrogens. I'm not going to write H plus little 2 because that tells me that 2 hydrogen ions are bonded together, and they can't be. They have the same charge. They repel. So instead, I put that big 2 in front to show me that they're separate. And again, even though it's written this way, if you drew out H2SO4, you'd have a hydrogen on each side of the SO4. They're not actually bonded to each other. HNO3, it's an acid, it's going to split, you're going to get H+, and you're going to get the NO3- ion, again another polyatomic ion. The last 3 are all covalent, they're not going to split, so they would stay as they are. If we look at some examples of questions now, this is a full equation, I'm going to turn it into an ionic equation. Br2 is covalent, doesn't contain ions, so I write it as it is. I don't leave it out, I write it down, but I just don't make any changes. Next up, I've got sodium iodide. It is ionic, so it does contain ions. It's got the sodium ion, and it's got the iodide ion. So I put a plus between sodium and iodine to show they're now separate. Because I'm showing them as ions, I need to include charges. Sodium's in group 1, +1, iodine's in group 7, -1. And that 2 there refers to the sodium and the iodine. So when I separate them, I need to put a 2 in front of both. Other side is really similar. I've got sodium and I've got bromine. I'm separating them, so I put a plus in between. Sodium's in group 1, +1 charge. Bromine's in group 7, -1 charge. The big 2 refers to both, so I put it in front of both. Iodine is covalent, it will not split. I write it down the same way. And the final thing to do is anything that's the same on both sides, exactly the same, you're going to cancel out. And the reason I do this is because if it's not changing, it means it hasn't lost or gained electrons, and it's not actually involved in the reaction. We call it a spectator ion because it doesn't change, it just sits back and watches. When we get rid of the spectators, what an ionic equation shows us is what's actually reacting. So bromine is reacting with the iodide ion, it's becoming a bromide ion, and you're forming iodine. Sodium is just sitting back, it's not changing at all. The ionic equation allows us to see that. The next equation is really similar. I've got chlorine. It is covalent, it's not going to split. I've then got potassium iodide, ionic and aqueous, it will split. So I've got potassium and iodine, I'm separating those with a plus. They're ions, I have to show them with a charge, +1 for potassium in group 1, -1 for iodine in group 7, and the big 2 refers to both. The other side is going to look something similar, 2K plus, 2Cl minus, going to I2, it's covalent so it doesn't split. K's cancel, what you're left with is your ionic equation. The next one, I've got sodium hydroxide, so we've seen this before. Sodium has a +1 charge. Hydroxide is a polyatomic ion. Don't separate the O from the H. HCl is an acid. Acids always split even though they're covalent. NaCl is ionic and aqueous. It's going to split into Na plus and Cl minus. H2O is covalent. It will not split. Cancel what's the same on both sides. The Nas go, the Cl's go, and I'm left with OH minus, and H plus goes to H2O. The next few all contain polyatomic ions, so I've written them here. Again, if you see one of these polyatomic ions, you don't separate them. So I have got KOH, all right, so OH is one of my polyatomic ions. I've got it over here, which means I'm not going to separate the O from the H. I've also got nitrate, NO3, another polyatomic ion. I'm not going to separate the N from the O. Everything else will split though, so the K will be separate from the OH. The H will be separate from the NO3. The K will be separate from the NO3. And then at the end, water covalent doesn't split. The K's cancel, the nitrates cancel, and you're left with exactly the same as what we had before. H plus and OH minus goes to H2O. And the reason they've got the same ionic equation, even though they have different starting equations, is because they're both neutralization reactions. And in a neutralization reaction, effectively all that's happening is H plus, OH minus combined to form H2O. The next one, sodium carbonate. Again, so here we see we have a polyatomic ion, so I'm not going to be separating that C from the O. I've got sodium, which is in group 1 with a +1 charge. I've got carbonate, CO3, 2 minus. I get that from there. And I can see from my formula that I've got 2 sodiums. Again, I'm not going to write the 2 down small. Those sodiums won't be bonded to each other. They repel. I've got 2 separate sodiums, so I'm putting that 2 in front. The 2HCl gives me 2H plus and 2Cl minus. It's an acid, so it splits. 2NaCl, 2Na plus, 2Cl minus. H2O, covalent don't split. CO2, covalent don't split. Na's cancel. Cl's cancel. What I'm left with is my ionic equation. Last one, again, another polyatomic ion, one you may be less familiar with, NH4, the ammonium ion. So I've got that there twice. So when I'm doing this, I'm not going to separate the N from the H. I've also got, which I'll do in a different color, I have got the hydroxide ion. We've seen this one before. I've got my OH minus ion there as well. So when I'm splitting these, I'm going to go NH4. I can see from my table, it's got a +1 charge, and OH minus. HCl is H plus and Cl minus. And then I've got NH4Cl, again my ammonium ion stays as is, Cl minus, and then H2O won't split. the NH4's cancel, the Cl minus is cancel, and again I'm left with H plus OH minus goes to H2O. This is another neutralization reaction. Next up, I'm going to do some exam questions, okay? Some of the exam questions are going to appear in the same type that we've been practicing. Some of them appear in a slightly different format. This first question is probably the hardest Ionic exam question I've seen. And the reason, they haven't given you the full equation. They've given you a bit of the Ionic equation, but without the full equation, this is actually quite difficult. So it's telling you that aluminium, which is a metal, reacts with dilute hydrochloric acid, and it's going to contain a solution containing aluminium ions. All right, what you need to know from this is a bit of background information from CC8 acids, which you covered in year 10, and that tells us that if we have a metal and we react it with an acid, we are going to form a salt and we are going to form hydrogen gas. So we can use the memory aid MASH, metal, acid, salt and hydrogen. So I would start by just writing out the full equation. So my metal here is aluminium. It's not diatomic, it's just going to be Al. My acid, they tell me, is HCl, so I'm going to write that down. The salt I'm going to form, if aluminium reacts with hydrochloric acid, is aluminium chloride. Aluminium chloride contains the aluminium ion, which has a +3 charge, the chloride ion, which has a -1 charge. So to work out the formula of aluminium chloride, I'm going to end up with AlCl3. Finally, I've got hydrogen, which is diatomic, so I'm left with H2. So that would be my full equation. I now just need to balance it, and once I've got my balanced full equation, I can turn it into an ionic equation just as I was doing before. I've got 3 chlorines on the right, I'm going to need 3 chlorines on the left. Annoyingly, that gives me 3 hydrogens on the left, and I've got 2 on the right. So this is a bit of an awkward one to balance. But you can use fractions or decimals when you're balancing. So if I've got 3 hydrogens there, what can I multiply 2 by to end up with 3? Well, the answer would be 1.5, and I can absolutely do that. I can write 1.5, because now I've got 1.5 times 2 is 3, and 3 over here. So my hydrogens are balanced. My chlorines are balanced, 3 on each side, and then my aluminium, I've got 1 on each side. Now, if you don't like the look of fractions, okay, in your balancing, to get rid of that 0.5, I would just need to multiply everything by 2. So if I multiply everything by 2, I end up with a 2 in front of the aluminium, a 6 in front of the HCl, a 2 in front of the aluminium chloride, and 2 times 1.5 is 3, a 3 in front of the hydrogen. Just double check that this is still balanced. 6 hydrogens, 6 hydrogens, 2 aluminiums, 2 aluminiums, 6 chlorines, 6 chlorines. Fractions are fine, but you can get rid of that 0.5 by multiplying everything by 2. In order to turn this into an ionic equation, I do need to know my state symbols, so I know what's going to be an ion and what's not. Aluminium is a metal. Metals are always going to be solid. Hydrochloric acid is an acid. Acids are always aqueous. Aluminium chloride, you're told you're forming a solution. If you're forming a solution, then that must be AQ, and hydrogen, you are expected to know, is a gas. So now that I've got my full balanced equation, I can turn it into an ionic equation. So aluminium doesn't contain any ions, so I'm going to be writing that as is, as Al. I'm then going to have H plus and Cl minus, all right, so they have the H plus in for me here. Actually, I'm going to write it out separate and then I can fill it back into their format, all right. So I would have Al, so 2Al, then I've got my 6H plus and my 6Cl minus, so I'm separating. And then on the other side, okay, you can see it's aqueous, so it's going to split, and I'm going to have 2Al3 plus, and I'm going to have 2 times 3, 6Cl minus, and then my H2 is not going to split, all right? So my chloride ions are spectators, they're gone, that's why they're not included here, okay, because they end up cancelling. So what I do have is I've got my aluminium, okay, which I know has a 2 in front of it. I've got my H plus, 6H plus. On the other side, I'm going to need a 2 in front of that aluminium, and then I'm also going to have 3H2. Again, just make sure it's balanced, 6 hydrogens on each side, 2 aluminiums on each side. That was for 2 marks. That one was hard. That was hard. The next one is easier, okay? They haven't given you a full equation, but in words they'll tell you that an aluminium ion reacts with a phosphate ion to form aluminium phosphate. You need to show an aluminium ion, so it's going to be an aluminium with a charge. It's in group 3, so it's got a 3 plus charge. They've given you the phosphate ion, and then they just want you to write the formula of aluminium phosphate. 3 plus, 3 minus, the charges cancel, so aluminium phosphate is just AlPO4. The next one again is a bit weird, but if you read it, it's not as bad as it looks. So blah, 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 blah. Complete the ionic equation for the reaction of calcium carbonate with magnesium ions. They've given you the formula of calcium carbonate. They want you to write the formula of a magnesium ion. Magnesium's in group 2. It has got a 2 plus charge. So that's all I need to do. Fill in my magnesium ion. And then I just need to make sure everything's balanced. So I've got 1 magnesium on each side. I have got 1 carbonate there, but I've got 2 carbonates there. So I'd need a big 2 here. And then I've got 2 calciums on the left, 1 and 2, 2 calciums on the right. So now it's balanced. The next one, again, they've written for you in words. So they're telling you that an aluminium ion, and they're even telling you the charge in the ion, 3 plus, reacts with a hydroxide ion. Hydroxide ions, OH minus, to give you aluminium hydroxide. Aluminium hydroxide, you're just combining these ions. If you've got 3 positives, you're going to need 3 negatives, which means I'm going to need 3 hydroxide ions. And that's going to be your ionic equation. Next one is more similar to what we've practiced. They've given you the full equation. They're asking you for the ionic equation. MgO is ionic, but it's solid, so it's not going to split. HCl is an acid, so it will split. MgCl2, ionic and aqueous, it will split, so I'm going to get Mg2 plus and 2Cl minus. H2O, covalent, no ions, stays the same. The Cl's will cancel, and what you're left with is your ionic equation. They are all of the ionic equations that I could find, but they do ask one every year, and it is typically the question that's answered worst on the paper. So definitely something to practice.